Hi, in this project, I'll be showing you how to create your own modern day record player using an Arduino board and radio frequency identification. RFID is the same technology used when we tap our credit cards or badges to enter a building. Each card in this project will have an ID that will either send an album to Spotify or control the Spotify player. That way, you can enjoy all of your favorite music without the distraction of a screen. To get started, download the code from the GitHub repository onto your local machine. It contains 3 sketches that you'll upload to your Arduino board and the wiring diagram to reference when configuring your hardware. Here's the list of materials that you'll need for this project. You'll need the Arduino MKR WiFi 1010, a USB cable and wall plug to plug into the Arduino. This project uses the RFID RC522 NFC reader and female-to-male jumper wires to connect your hardware together. For the NFC tags, I used the round coin and mini rectangular ones. You can use whatever NFC tags you want to, just make sure that they say MIFARE Ultralight. And you'll also need a soldering kit so that you can solder your pins onto your RFID reader, which you'll do in the next step. So if you didn't get an RFID reader that comes with pre-soldered pins, you're going to have to solder the right angle header pins onto your RFID reader. If you're unfamiliar with soldering, it's a method of fusing 2 metal components using a special metal alloy called solder. It's best to get a practice kit if you haven't done it before, or luckily for me, a partner who works with hardware. Once the pins are soldered, you'll see that on top of each pin are labels, and you'll also see on the Arduino board that the pins are labeled here as well. So most of the pins will be connected to the same name, but refer to the wiring diagram for the configuration between both devices. What I like to do is connect all of the cables onto the RFID reader first. Just be sure to skip the IRQ pin. And you don't have to use the same color wires that are on the wiring diagram. I just did it that way so that it's easier for me to see and connect the cables. Moving on to the Arduino board, I connect the pins going from bottom to top. So starting at pin number 6 on the Arduino board, if you look at the wiring diagram, it connects to the reset pin on the RFID, which for me is the yellow wire. Next is pin number 7, which connects to the SDA pin on the RFID. And for the most part, from here out, all of the labels on the Arduino board and the labels for the pins on the RFID will be the same. So the MOSI pin on the Arduino to the MOSI cable on the RFID. And the same goes for the SDK, MISO, GND, and VCC pins. And here's what it should look like when all of the wires are connected together. Now you can grab your USB cable and plug the Arduino into your computer. If all of the configuration is successful, you'll see an orange and green light on the Arduino board and a solid red light on the RFID reader. Before we jump into the code, you'll need to set up your Arduino environment by downloading a few things. The first thing you'll need is the Arduino Create agent. This enables you to upload sketches from Arduino Cloud onto your board. And be sure to activate the app after installation, either by searching for it or clicking on the icon at the top of your computer, and you should see that the Create agent is running. Next, sign up for an account on the Arduino Cloud. Once you go through the registration process, it'll ask to verify your email. And once your email is verified, it'll take you back to the IoT Cloud homepage. From here, navigate to IoT Cloud and create what Arduino calls your first thing. To create your first thing, you'll need to associate your device and enter your Wi-Fi information to configure the network settings. And from here, we're able to use the Wi-Fi feature. Lastly, download the Arduino IDE, and this is where you'll write and upload your sketches onto the Arduino board. Once installed inside of the IDE, go to the board manager and install Arduino SAMD boards, and that allows us to use our Arduino MKR WiFi 1010 board. And next, in the library manager, you'll want to add the following libraries: Arduino JSON by Benoit, Arduino HTTP client, and the MIFARE RC522 by GitHub community. Lastly, select the board and port that your Arduino is connected to. Now you'll need a place to store all of your album data before you import it into the code. So I made a template on Google Sheets that you can use that will store all of your album information as well as format the links so you can send it to the Spotify API later. So when you're on Spotify, search for all the albums that you want, get the album link, and put them in the right columns into the spreadsheet. And I'm gonna add a couple more albums so I can use them as an example in the demo. The Spotify APIs used in this project can also play artists and playlists, but not individual songs. This would also be a good time to either write on your NFC cards which albums they are or which control cards they are. And you'll see that I created album sleeves and decorated cards for them. And you can learn how to do that in my next video. But for now, we'll just test with the NFC cards we have. Now we can jump into the code. Starting with sketch number 1, get card UID. This code detects and reads the unique ID of each NFC card when it's tapped onto the reader. Once you have the file open, upload the sketch to your Arduino and open the serial monitor. Before you start tapping the cards onto the NFC reader, it's really important that you arrange the cards in order that they are on the spreadsheet so we can again associate each card to the correct album. Now you can tap all of your album cards onto the RFID reader. You'll start to see in the serial monitor that the ID for each card is populating. Continue to do this for all of your cards, and once you've tapped all of your cards, copy the list of IDs and put them into the card UID column in the spreadsheet. And when you're ready, you can clear the serial monitor and repeat the process for all of the control cards. To use the Spotify player with your Arduino board, you'll need to set up a Spotify app and authorize it for your project, which is what you'll do in sketch number 2, Authenticate Spotify. To create an app, go to the Spotify developer dashboard and log in with your Spotify credentials. Then you can go to the dashboard and click on the button that says Create an App. Here you can fill out all of the app information, and for now you can put dummy links inside of the website and redirect URI fields because you'll need to have your IP address in order to fill those out. And once you've created the app, go to settings and copy the client ID and the client secret into the Arduino secrets.h file in your Arduino IDE. Here you'll also want to fill in your Wi-Fi name and your password. Now you're ready to upload the sketch onto your board, and also be sure to open the serial monitor so that you can see your IP address. And once the sketch is uploaded, inside the serial monitor, you'll see Please Authenticate at your IP address. And this is the IP address of your Arduino board. Now inside of the settings again of the Spotify app, replace the links that we put in the website and URI fields in the format that you see on the screen. Once you save your changes, we'll actually need to navigate to that link, so open up a new tab or window and navigate to that web page. On the page, you'll see that it asks us to authenticate Spotify, so when you click on the link, it'll take you to Spotify's OAuth flow, and once you agree to the terms, back on the web page, you'll see that you're now authenticated to use the Spotify APIs. And going back to the IDE inside the serial monitor, you'll see the refresh token, and just save this somewhere so that you can use it in your next sketch. And now onto the most exciting part of our project is our main sketch, so that when an NFC card is tapped, this code will read the card's UID and send either an album or a control via the Spotify APIs. So first, copy and paste the values you had in the Arduino secrets in sketch 2 into this Arduino secret file. including the refresh token as a variable, especially in the one that's provided, because we'll be using that in the actual code. And now you can go to the albuminfo.h file and copy all of the album UIDs, album URIs, control UIDs, and control actions from the Google Sheets into the corresponding arrays of this file. When you're ready, you can open the serial monitor and upload your sketch. Before you move on to the next steps, inside the serial monitor, make sure that you see it's connected to the Arduino IoT cloud. And this can take a couple minutes, but this will allow us to use Wi-Fi and then send our APIs. To control the Spotify player, you'll need to connect to an active device, and this is the only time that you'll actually need to open Spotify. And you should see that there's an active device because of the green banner that pops up. Now you can start tapping your cards and they'll play on the device that you selected. As you can see, I tapped A Seat at the Table by Solange and then it started playing on the player. And next is Aromanticism by Moses Sumney, and that album will start playing as well. Here you can also test out your control cards. So in the serial monitor, you'll see that the control is shuffle on, and in the Spotify player, the shuffle feature turns green. This is the next song card, and it'll allow the player to skip to the next song. You see the song change, and then let's just skip the song one more time. The last card I'm testing out now is the pause, and you see the player go from the pause button to the play button. And that's a wrap on our project. You can disconnect the Arduino from your computer and plug the USB into a wall charger so you can use the player. I really hope you enjoyed this project and continue to find joy in it. If you want to learn how to make the albums, feel free to subscribe and stay tuned for upcoming videos. Thank you!